Hi guys, in this video we are going to learn another interesting question from electrical fundamentals. I have already uploaded many videos regarding these questions. If you like to watch them, I have given the links in the description so you can watch whenever you can for free of charge. Also, I have given the website link so you can find those questions in an order. So here we are going to discuss about the parallel circuit question, which mainly have two electrical components. They have given the impedance also. Before we seeing the question, just copy this data. Also, if you are new to this expert tutor channel, please don't forget to subscribe it. Okay, I'll read the question now. Two impedances, Z1 is equals to 8 plus J6 omega and Z2 is equals to 3 minus J4 omega are connected in parallel across a 230 voltage 50 Hz supply. So they have given this information. The first part they are asking to calculate current in each branch. Second part, line current. Third part, total impedance. So they are asking three different questions. I hope you have already noted these questions. Just pause the video and try it in your own. After that, you can check your answers with mine. So in this question, we need to consider a parallel circuit. Also, they have given the impedance. That's the main point. So when we are using this one, we need to consider a circuit. If we draw a circuit, random circuit, it would be a little bit easier for us to figure it out how to do this or how to solve this question. So I'm going to draw simply a circuit. Sorry. Okay. So here we are given that two electrical components are in parallel. But the main thing is we don't know whether this circuit contains resistor or capacitor or inductor. But from our previous knowledge, we can directly tell that it always containing a resistor part because it has the real part of impedance, which means this is a resistor. Also, it is having the reactance, so it would have either inductor or capacitor, but there won't be chance to have only capacitor inside this because it's having a plus sign. There would be always an inductor, but there might be a capacitor with that inductor. So we don't need to bother about that because they haven't asked anything about that, but they have given two electrical components and the impedance. So I'm going to mark it as Z1, Z2. The next part is, the first part is we need to find the current for each branch. So I'm going to mark it as I1, I2. When we are considering a parallel circuit, the main idea would be we need to take the voltage differences between two components would be the same, which would be 230 voltage. So I have marked that. So from that, we are going to find the I1. Before that, I know that on this first component is going to have the voltage difference of 230 voltage because I have already mentioned that when we are considering the parallel circuit, we already know that both two components or any of other lines in that parallel circuit would be having the same voltage difference. So when we are using this, we need to find out the current using this data. We know the voltage value, which is equals to 230 voltage. Also, we know the Z1 value, they have given that. So when we are using this, we should use V is equals to I into Z. But when we are considering that, we already know the value of voltage, which is equals to 230 voltage. And if we consider the I value, we need to find this I1. And we know the Z value, which is equal to 8 plus J6. But here the problem is whether we need to change this for polar form or Cartesian. because they have given the impedance in Cartesian forms, and we don't know what's the value of, whether we need to change it to Cartesian form, which simply means 230 plus j, 0, j into 0, or we can either make it as the polar form, the 230 voltage and the phase angle. But we can directly tell, when we are going to consider the parallel circuit, we can directly use the voltage is as a reference line, which means the voltage phase angle would be 0. So if we consider that, if we change that to complex number, we will get 230 plus j into 0, because we have considered that it would be in the reference line. So j into 0, which we will get at the same answer, 230. If we consider the polar form, we will get 230 into this angle. However, according to my view, it would be easy if we choose like polar form, and if we convert this to polar form and solve that. However, when we are using the calculator, it won't be big issue if we use the complex numbers too. So let's try it as complex number. If I use this, I will be getting 230 plus j into 0, so I'm not going to write that. And if I'm going to divide it by 8 plus j6. If I simplify this, I'll be getting the answer, the complex number answer for I1. However, the main thing is, I have already uploaded a video how to solve the complex number using calculator. If you haven't watched those, or if you don't know how to do this, just watch that, because it would save your time a lot. So I'm going to type this in on my calculator. So if I type this, and 230 divided by 8 plus I into 6. I'm getting 92 by 5 minus 69 by 5. This is the ampere, because we have given the impedance in ohms and we have given the voltages in the voltage, so we will directly tell it's going to be in amperes. So we will get this answer. This is going to be j. So 92 by 5 minus 69 by 5 into j. So you can use either decimal points to show that. In similar way, you can find the value of I2. For I2 also, we are going to take the voltage phase angle as 0. So we can directly use this. So if we use that one, we are going to get I2 is equals to 230 over 3 minus 4j. So you can use your calculator to solve this. You will be getting an answer for this. So it would be also equals to something, an ampere. So I'm not going to show that. From that, they are asking the total line current. The thing is, if you find the answer in the polar form, it would be difficult to directly add those things. I'm going to do that. I2, I'm going to figure out the I2, because it would be useful if I to continue the second part. So 3 minus 4i, it would be 138 by 5 plus 184 by 5. So this is the answer, j. So here I have already found the I1 and I2. So when we are considering the total line current, we need to add up. The main thing is why I have found that when you are using the Cartesian form, you can directly add the real part and directly add the imaginary part. If I add this, I'll be getting 140, 90, 230 by 5. And the imaginary part you need to deduct, because there is a minus sign. So it's going to be deduct and you will be getting the answer. But when you are using the polar form, you can't directly add like that. For an instance, if I take that here, if I take that as 10 at 20 phase and 20 plus 30 phase, 20 ampere in the 30 phase. You can directly add 10 plus 20 is equals to 30 and 20 plus 30 into 50. You can't add like this. That's the biggest problem. But if you are using the calculator, you can add and consider the value. It won't be like this, but you can get the value. But if you are doing manually, try to do with this complex number, otherwise it would be difficult. You need to change this for complex number. After that only we need to find the answer. So it would be easier if you use complex number if you are using manual methods. The last part, they have asked the total impedance of the circuit. As we all know, when we are considering the total impedance, we have given that it's in the parallel circuit. So when we are having the parallel circuit, we need to remember, we need to add up the admittance of the circuit to get the total admittance. The admittance, we already know the admittance is equal to 1 over impedance. So we need to find the admittance for each circuit, and after that only we need to add it up. If we add up, we are going to get the total admittance of the circuit. So I'm going to do that. So if I do that, I have already given that we are going to find the admittance. Admittance is equal to 1 over impedance. So if you find that, we already found, they have already given the Z1. So from that we can get the 1 over Z1 is equals to 1 over 8 plus J6. If we calculate this, we are going to get the omega minus 1. In the similar way, we can find the 1 over Z2 and 1 over 3 minus 4J equals to omega minus 1. We need to figure it out. After that, we can directly add those. So y is equals to y1 plus y2. Why are we adding this rather than adding the impedance? The main thing is, if we are connecting the circuit in this parallel mode, we need to remember we are going to add this admittance. If we are having a series circuit, we can directly add the impedance. So it would be little difficult than series circuit. However, totally it's not difficult if we are using the calculator. So we can directly get an answer for this, and after that we can directly substitute. If we are using the complex number, it would be easier for adding those. So we will get the final answer. After that, we need to find the total impedance. So we need to find by using Z is equal to 1 over Y. After the finding the Y, we need to change and find the Z value for that. So I hope this video would be useful for you. If you have any doubts, just comment it below. I already mentioned that if you are new to this channel, don't forget to subscribe it and put a like. Thank you.